present here. I am T. Prem Kumar, SM Professor, Department of Computer Science. Today I am going to take a class on computer, that is mobile computing, in Unit 1 to Unit 5. The important topics we are going to discuss it. We will start one by one. So the first we will see about the introduction of the mobile computing. So when we talk about the introduction of mobile computing, so it is a technology that allows the transmission data, like transmission of data, voice and the video through a wireless enabled devices without being restricted to a fixed physical connection. So this is what the general introduction about the mobile computing. It enables the users to access computing resources and network services anytime and anywhere. So the features, the key features of the mobile computing are, first one is the portability. A device can be easily carried and used on the move. The second one is the wireless communication, the connectivity through the Wi-Fi, cellular networks as well as the Bluetooth, etc. Then the third one is the remote access. When you take about the remote access, the user can access the applications and the data from any locations. Then the third feature is, after the third we have the fourth one, that is real-time connectivity. When you take the real-time connectivity, the instant communications and access to the online services has been enabled. Then the last one is energy efficiency. It is optimized power consumption for the battery operated devices. So this is the key features of the mobile computing. When you talk about the next continuity of the components of the mobile computing, that is, the first one is the mobile devices, second one is mobile softwares and the wireless communications. So when you take a mobile devices, the smartphones, tablets, laptops, wearable devices, etc., which comes under in the mobile devices, and the mobile softwares, which takes about operating systems, applications and the cloud services which involves in it. And the third one we have, that is wireless communication. The technologies like 4G, 5G, Wi-Fi and the Bluetooth, NFC and satellite communication has been involved in the case of wireless communication. Then we'll see about the applications of mobile computing. The applications we have something like business and commerce, which is being used in banking, online banking, e-commerce and remote works, etc. Then the second area what we have here is the healthcare, which is like telemedicine, health monitoring apps, wearable health devices, etc. And in the case of education, the education is the e-learning platforms, mobile apps for learning and virtual classrooms. Then the fourth one is entertainment. Here the entertainment is for the streaming services like gaming and social medias. The last one is the navigation and the transportation. Here the GPS navigations and ride-hailing apps and vehicle tracking. These are all some of the applications that have been used in the case of mobile application. Next, we'll see about the mobile computing and as well as the wireless networking. So when you compare these two technologies, so both mobile computing and the wireless networkings are essential in the modern communications and the computing. However, they have the distinct roles and the purposes which involves in it. We'll see the mobile computing as well as the wireless networking. When you take the first point, that is the definition part, it is ability to use the computer devices and access data remotely while using mobiles. In the case of wireless networking, it is just communicating without any physical cables. Then the second one, when you take the primary purposes in the case of mobile computing, it provides the computing and the communications capabilities anywhere and anytime. In the case of wireless networking, it is going to establish the connections between the devices and for the data transfers. Then the third one, the components, what are the key components is going to involve here is, in the case of mobile computing, we have something like mobile devices, mobile OS and cloud services. And in the case of wireless networking, we have wireless routers, access points and mobile networking, etc. Then the next one we have, that is dependency. Here the dependency says the required wireless networking for the communication, but also involves computing and the softwares. And for the wireless networking, it focuses on the connectivity and the data transfers between the devices. Then the next one is mobility, which supports that is the mobile computing, which purely supports on the full mobility, allowing the users to compute and communicate on the go. So in the case of wireless networking, can support mobility but primary aims to the wireless data transmissions. Then the next one is an example. So we have in the case of smartphones, tablets, laptops using cloud computing of the mobile apps in the case of mobile computing, and in the case of wireless networking we have that is Wi-Fi, Bluetooth, cellular networks and the satellite communication is being used. The next one is the challenges. When you take about the mobile computing, the challenges which takes about says about the security threats and the battery limitations. Finally, the network's dependency has been involved in the case of mobile computing. And then next we'll talk about the challenges in the case of wireless communication, that is wireless networking. So signal inferences will be there and the dependency limitations will be there, and finally the security risk is also involved in the case of the wireless networking. Next we'll see about the structure of the mobile computing applications. So when we talk about the structure of the mobile computing, so the mobile computing application is a structure to ensure the seamless interactions between the users, device, networks and the backend services. So it consists of multiple layers such as playing each and every role plays a crucial role in delivering the functionality and the performance. Now we'll see one by one in the case of this. So the first one, the first layer what we have here is user interface layer. So we also call it as a front end. So in this the presentation layer where the user interacts with the applications. Then it has been designed for the usability, responsiveness and also the accessibility. Then it is built with using the UI workspace like React Native and Flutter as are also the Swift UI. The components involved in this user interface layer is we have something called touchscreen UI interfaces like buttons, forms, navigations where the user is going to interact with it. And the next one is voice command, and it's just based on the voice it is going to do the command as well as the operations. The third one we have that is interactive elements like animations as well as the notifications. Then the second layer what we have here is application layer. We can also say it is in the business layer, handles the data processing as well as logics and the workflow of the mobile apps. It is telling about how the data is going to process and how it the logics as well as the workflow of your mobile apps. Then it also ensures the smooth interactions between the UI and the backend. The next one, it is developed using the programming language like Java and Kotlin. So Swift Draft as well as the JavaScript is been used for the it are used to create the applications layers. The components involved in this applications layers are, one is the business logics and the core functionalities. Then the second one is the API calls for the backend communication, and also we have something called offline storage as well as the caching. So this is the third layer, which is also called as a business layer or business logic. Then the third layer, that is middleware layer, which is mainly used for the connectivity as well as the security. It is going to act as a bridge between the mobile app as well as the backend services. It provides the authentication, security and communication protocols. Then the another point what we have, it is going to ensure the security data transfer through the form of an encryption. The components involved in this middleware layer is the authentication and the authorization, that is authentication and authorization has been involved, and then the data synchronization will be there, and the cloud integration as well as the push notice will be there in the case of the middleware. Then the next layer we have, that is a data management layer, where the data is going to be stored as well as retrieved, and the processing of the data involved in this layer can store the data locally or connected to the cloud-based databases, which uses the SQLite, Firebase, Realm or no SQL databases. These are the applications that we use to develop the data management layer. And the fifth layer we have, that is network layer. It is also called as a wireless communication. We know very much that the mobile communication is purely works in the platform of the wireless. It ensures the real-time data transmissions between the devices and also the remote servers. So what are the uses in the case of network layers is, that is the Wi-Fi, 4G, 5G, Bluetooth, NFS as well as the VPNs for the connectivities, and which includes the networking optimizations techniques for the low latencies. And the last one, that is backend layer services, which is service side processing layer involved in the case of mobile computing. It is for host and processes the data, APIs and the business logics. on the remote servers. Next one, it ensures the secure transactions, user management, and the database operations. The last we have, that is, it uses the cloud platforms at AWS, Google Cloud, and the Microsoft Azure. Then the next topic what we have, that is the mobile internet protocols and the transport layer. We'll see about what are the protocols first we're going to have it in this, and how it is going to be involved in this case of mobile computing. So when you take the mobile internet protocols and the transport layer, so the mobile computing relies on the robust networking technologies, includes the mobile internet protocols like MIP and the transport layer to ensure the seamless connections across the different networks. The key components of the mobile IP is, that is, the home agent, we call it as an HA, and the second one is the foreign agent, that is FA. The third one is mobile node MN, and the last one, that is corresponding node CN. So when you take a home agent, it is telling you about a router in the mobile node's home networks that keeps tracks of the mobile node's locations. The second one, that is foreign agent, a router in the networks where the mobile node is currently roaming over there. Then the mobile node, the device that moves across the different networks, that is, for example, so when you are using within a smartphones and laptops, so when we are moving in some other locations, some other places in roaming regions, so automatically the device is going to be traced using this particular mobile network. Then the next one is corresponding node. This devices is communicating with exactly to their mobile node. So this is what the key component in the case of mobile application. And the next one is the mobile, that is working of the mobile IP. When you are working with the mobile devices, that is in the moving state, the foreign network is, first it is used to register with the foreign agent. Then when you are registered with a foreign agent, then automatically the home agent will forward the data to the new locations using the tunneling process. Tunneling process is nothing but it is going to divert the data to the mobile node by finding out the or tracing out the network's path. The next one is the foreign agent. The foreign agent delivers the data to the mobile devices, and this ensures the seamless internet access and along without changing the device's IP address. So this is what the general working process of a mobile IP. Then the next one, the second layer what we have in the case of mobile computing is, that is the transport layer in the mobile computing. The transport layer, we know it is used to helps to transfer the data from the one devices to the another devices. That is what we have here. That is managing the devices to end-to-end data transfer. It operates above the network layer, that is, and after the network, before the network layer it is going to work, and below the application layer it was there. And the key protocols of the transport layers is the transmission control protocols, the major protocol used in the case of mobile IP, which is going to ensure that whether it is being transferred the data in the reliable format, or it is going to ensure that if there is any error, or it has been eliminating the errors, and this sequential data delivery is also being plays a major role in the case of transmission control protocol. Then the second one is user datagram protocol, that is UDP. It is going to provide you the faster connectionless communications without guaranteeing the delivery. So why? Because when you take about the UDP, it is a user datagram protocol, so you cannot able to expect the accuracy of your data whatever it has been delivered. The third one is the stream control transmission protocol, that is SCTP. It is a hybrid of TCP as well as the UDP. It is used for the voice over IP as well as in the case of voice over data transmission in the case of telecommunication services. The next one, we'll see about the comparisons of the TCP as well as the UDP in the case of mobile computing. So the TCP, when you talk about the reliability of a TCP, it was high, but in the case of UDP, it was low. And the second one, when you take a TCP, the speed of the TCP is slower than due to the error checking. But in the case of UDP, it was voice over IP, that is voice over internet protocol is streaming and online gaming is being there, and the speed when you compare to the UDP, it is faster for the real-time application. Then when you take about the TCP use cases, where we can use, that is, we can see it in the case of web browsers, emails, as well as the file transfer, and the UDP is for the voice over internet protocol as well as the streaming, and for the online gaming we can use it there. Then the connection time, so TCP is a connection oriented and the UDP is a connection connectionless, we call it. This is physical connections we cannot able to see it in the case of TCP, and UDP the that you can also cannot able to see any connection list. That is, in simple term, we want to say means it is wireless and it is being wired. So TCP is in a wired as well as the UDP is in a wireless form. Then we will see about the architecture of TCP as well as IP. So the TCP IP overview is it has 4 layers. Unlike the OSI models which has 7 layers, but in the case of TCP IP layer which has only 4 layers, each layer is responsible for the specific networking function, and this model supports reliable communication across the different network architectures. So we will see one by one what are the layers we have in the case of TCP IP models. The first one is network access layer, which handles the physical transmission of data over a network hardware. For it is an equivalent to OSI layer, which we take it as the physical as well as the data link layer. The last column it is telling you about the OSI layer, which we know it is having 7 layers. But in the case of network access layer, in the case of TCP IP, which combines both physical as well as the data layer of the OSI. Next is the second one. When you talk about the internet layer, it is handling for the address, routing and the data packet across the networks, and which involves in the case of network layer in OSI. Then the third layer of the mobile IP, that is TCP IP, is the transport layer, which ensures that the reliable data transfer and data is going to be transferred between the devices, either it may be a TCP or UDP. It was similarly as what we have used in the case of the OSI. Then the next is the fourth layer, that is application layer. This application layer provides services to the applications for the data communications, and that is equivalent to your OSI layer is application presentation and session. So this is what the general layers what we have in the case of TCP IP, and we will see in detail about how the network layer is going to be work. So it deals with the hardware connections using Wi-Fi, Ethernet and the cellular networks, and it is also going to ensure that there is no error detections, and ensures the error detections, frame transmissions and the MAC addresses. And protocols used in this is Ethernet protocol has been used with the Wi-Fi, that is version 802.11 version has been used, and the address restriction protocols have been used in the case of network access layer. Then the second one is internet layer. The internet layer, it is responsible for the IP addressing and packet routing, and also for the fragmentation, which ensures the data reaches the correct destinations across the multiple network. The protocols what are used in the case of internet layers is the IP protocol, that is internet protocol. It defines the IP addresses and the routing places, and the ICMP, which is internet control message protocols, which helps to error reporting as well as the diagnosing the errors. Then the next one is the ARP, that is address resolution protocol. This address resolution protocol is used to map the IP addresses to your MAC addresses. Then the third one is transport layer. It ensures reliable end-to-end transmission for your communication. Then it manages error detections, flow control, and also for your congestion controls has been taken over here. The key protocols involved in the case of TCP is TCP, there is a transmission control protocol, which is for reliable connection-oriented communications. Then the UDP, it is user datagram protocol. It is for faster connectionless communication, and SCTP, that is stream control transmission protocol. It is used for voice over internet protocol and the mobile networks. Then the fourth one is that is application layer. This application layer provides the user facing services using web browsing, emails as well as the file transfer applications. So users various application specific protocols for the communications are, that is the protocols normally what we have used in the case of application layers is HTTP and HTTPS. It is used in the case of web browsing, and HTTP is for the file transferring, and SMTP as well as the POP3 or IMAP emailing services. These protocols will use in the email services. The last one is DNS, that is domain naming services resources, is also being used in the case of application layers. Small comparisons with your TCP as well as the OSI model is, so when you talk about the TCP which has 4 layers, in the case of OSI we have 7 layers, and the second one, it was developed by DoD, that is Department of Defense, but in the case of OSI it was developed by the International Organization for the Standardization. Then the primary use of the TCP is internet as well as the mobile networking, and that is for the OSI is a general networking process. Then the last point, when you take about the reliability means it uses TCP for TCP IP is only for the reliable transmission, and in the case of OSI, it uses the various transmission protocol for the reliability. Then the next topic what we have, that is the global systems for the mobile communication, that is GSM. It is a very important topic. So GSM is in a global system for mobile communication. It is a standardized global cellular networks used for the mobile communications. It was developed by an European telecommunication standards institution, that is ETSI, and it is foundation for the modern mobile networks. So the key features of the GSM is, so it was a digital communication which uses the digital signals for the better quality as well as the security. Then the second one is the international roaming. It allows the users to connect to their networks globally across the universe. Then the SIM card based, that is SIM cards for the subscriber and the authentication process is being involved. The next one is support for voice and data, which enables calls, SMS, and also the internet accesses. Then the last one is the security and encryption, which ensures the secure communications using the various encryption techniques for your security purpose as well as the protection purpose. The next one we will see about the GSM architecture. In the case of GSM architecture, it consists of several interconnected components that manages communications and the data transfer. See, so it is going to interact with an interconnected components that is going to manage the communications and the data to transfer. Then here in the case of GSM architecture, we have first one, that is mobile station, that is MS, which is nothing but the user mobile devices like phones as well as tablet, etc. So it contains the SIMs, that is subscriber identity module card, which stores the subscribers' data. Then the second one is the base station subsystems, that is BSS. It manages the radio communications between the mobile devices and the networks, which includes base transceiver station, that is it is going to act as a transfer as well as receiver. So the station is going to transmit as well as receives the signals to and from the mobile devices, which handles the communication within the mobile phones. Then the base station control, that BSV, which manages multiple BTS units, that is base transceiver stations units, and assigns the radio frequencies. Then the third one, that is network and the switching subsystem, that is NSS. So controls the call routing and authentication, finally for interconnections. The components which is involved here in it is, that is mobile switching center, we call it as MSC, which routes calls and manages the connections. Then the second one, that is home location register, that is HLR, that is stores the subscriber informations and the locations. Then VLR is nothing but visitor location register. It temporarily stores the data of the roaming users. Then the last one we have, that is authentication center, that is it ensures the security using the encryption keys. The next one, the operations and the support subsystem OS, that is OSS, we call it as an OSS, that is for operations and support subsystems. It monitors and manages the networks for the maintenance as well as the quality controls. Next we'll see about the networking services. When you talk about the networking services, we have 4 to 5 services. One is voice call, which is standard mobile. Whatever the standard mobile we have, all these calling services which will comes under your voice calls. Then the second one is short message service, we see is an SMS, that is only for texting messages. And the next one is data services. We have able to use internet access using GPRS in the case of 2G and H in the case of 2.5G generation, and UTMS is for your third generation. And also we have something 4G, 5G concepts. It is only purely talking about the data services. Then the next one is we have something called multimedia messaging services, MMS, by sending pictures, images as well as the audio to another person, from one person to another person, so like one device to another devices. Then the next one is the supplementary services, which is going to have the information about call forwarding, call waiting as well as voice mailing. So this is the general services we have it in the case of GSM network. Next one, we have something called advantages of GSM. So when you take a GSM advantage, it can be used in a widespread coverage. What is the meaning of this is, So it is used to cover up to 200 countries. See, we can able to cover GSM up to 200 countries, and high security, which uses the security for the secure communication, that is which uses encryption concepts for the secure communication, and also it has the efficient spectrum use which supports multiple users efficiency. Okay, then the next one is the low cost device as well as services. When you take in a mobile device, it is affordable mobile cost, and the plans is also affordable for the users for your data transmission. Then next we'll see the disadvantages of the GSM. So the GSM is telling about the limited data speed, so it can slower compared to the modern technology like LTE as well as and the 5G. So now we are currently using the LTE as well as the 5G network, but in the case of GSM, which is below version, that is to 3G speed there, so the speed of the network is going to be a little bit slower when it has been compared with a 5G network. Next, the signal inference is also be there, which affects the buildings as well as the weather conditions. Next, the security risk is being there, that is we have something, we thought that the encrypted still have some vulnerable to hacking will take over there. Next, the evolution of GSM from the 2G to 5G. So we have something called the second generation, that is GSM, which has the GPRS as well as the Edge technology, and which can able to transfer the data in the speed of 56 to 236 kilobytes per second. And whereas the main features, what is the main features we have, that is voice as well as the SMS. Then the second type we have, that is 3G, that is UMTS. Okay, it is for the HSPA as well as HSPA plus technology is being used, and it can be see the speed that 2 Mbps to 42 Mbps, which has been totally different when it be taken in the case of previous one. So the previous one we have talked about only the kbps, but now in the second case, that is third generation, we have something called like 2 GB, that is 2 Mbps to 42 Mbps speed connection will be there, which will provide the faster internet as well as the video calls. Then the next one is 4G, that is LTE, which is having the technology of LTE as well as LTA technology has been used, and it can be capable of transferring the data with the speed of 100 Mbps to 1 Gbps speed will be there, and it is main features involved in it is HD video, VoLTE as well as IoT supports is being used in the case of the 4th generation. Then the 5G, it is for NR, that is new radio, which is capable of 1 GB to 10 Gbps speed, and which is for the ultra speed, low latency, and for the AI integrations. The next one we will see about the mobile ad hoc network. So when you take about the mobile ad hoc networks, that is the introduction of the mobile ad hoc network is, it is a decentralized and self-configuring wireless networks where the mobile devices communicates without relying on the fixed infrastructures like routers or any base stations. We can say that without the access point, we're going to transmit the data from one device to another device. That is what we have in the case of mobile ad hoc network. So each node in the mobile ad hoc networks is act as a host and as a router. So this is how it is going to use in the case of forwarding the data for the another node dynamically. So the key features involved in the case of manage is infrastructure is less, that is no centralized administrations or fixed infrastructure is required. And the second one is the self-configuration. The self-configuration device, it's telling about the node automatically detects and joins networks. And the third one is dynamic topology. The dynamic topology is nothing but the networks continuously changes as the nodes moves. Okay. Next one is the multi-hop communication, where the data is relayed through intermediate nodes. So it's going to be transmitted the data within the intermediate nodes. The last one, that is energy efficient. It is optimized for the low power consumption in the mobile devices. Next, we'll see about the architecture of the MANET. So when you talk about the architecture of the MANET, which has nodes, that is we simply call it the mobile devices, a smartphone, laptop, IoT devices, drones, etc. And each node can send, receive as well as the forwarding the data. So the next one, the protocol, routing protocol is where, since there is no central routers, the MANET is use the dynamic routing protocols involves there. Then the communication links here, the nodes communicating using the wireless signals by using Wi-Fi, Bluetooth, radio frequency or any satellite links. Then the next one, distributed controls. The nodes are independently determines the route, determines the best route of the communications. Next, we'll see about the types of the MANETs. So when you talk about the types of the MANETs, if we have something called vehicular ad hoc network, we call it as a MANET. It is used for the intelligent transport systems for vehicle to vehicle, that is B2B communications. Then the second one is tactical networks, which is used by the military and the emergency services for battlefield communication. Then the sensor networks, it is used for the environmental monitoring, disaster responses and any other IoT applications. The routing protocols in the MANETs which has the routing in the MANET is challenging due to the frequency topology changes. MANETs use three types of routing protocols. One is proactive, second one is reactive, and the third one is hybrid. So when you talk about the proactive, that is the nodes maintain up-to-date routing tables, and the second, in the case of reactive, the routes are created only when needed. The third one is hybrid, which combines both proactive as well as the reactive approaches. Next, we'll see about the advantages of the MANET. When you take about the advantages, so it is going to tell you about no infrastructure is required and it can be deployed quickly in the remote access, highly scalable and robust, and fault tolerance is there, cost effective. So these are all the advantages in the case of MANET. When you talk about the applications, so military communications will be there, disaster recovery process will be taken over there, and transport, smart transport is being used in the case of MANET, and healthcare IoT as well as the environmental monitoring. Next, we'll see about what are the popular routing protocols in the case of mobile computing and the networks. So there are several popular protocols that have been used in the case of routing protocol, that is proactive. When you take a proactive, it is continuously updating the routing tables even if not needed, and the reactive is nothing but routes are created only when they are in the need. Hybrid is, it is going to be a combination of both, and geographical based, it is uses the nodes, it is uses nodes locations instead of routing tables, and the hierarchical, it organizes the nodes into the clustering for the scalability. Next, we'll see about the proactive routing protocols. These protocols maintains the up-to-date routing tables for all the networks which has been connected into it. Then the second, we have something called destination sequence distance vector is being used, and as well as the optimized link state routing protocols is being used. So I'll just give an outline of this. So when you take a destination sequence distance vector, which is each node maintains a tables with the shortest path of the each other nodes. But in the case of the optimization link state protocol, it is used to based on the link state routing, but optimized for the wireless networks, and also the sequence number in the case of DSDB, it is used for avoiding routing loops. But in the case of OLSR, it uses multi-point relay, that is to reduce the redundant broadcast. And we have something called pros and cons as both the category. So the pros ensures the consistency, routing with the low latency, but then its efficiency is dense network and faster routing discovery than the DSDB. Next, the cons, it high overhead due to the frequency table updates and no scalability for the larger network. But in the case of OLSR, we have something high control overhead in the case of the larger network. The next one we have, that is hybrid routing protocol. The hybrid routing protocol is nothing but it is a combination of proactive as well as the reactive features. It is used for balancing efficiency as well as the scalability. So here it uses a protocol called a zone routing protocol, which divides the network into zones, and by proactive routing within the zones and reactive between the zones, this has been the concept involved in it. So the pros, the positive point what we have here, it reduces the route distance latency, and also it reduces and it also increases the efficiency for the larger network. Then the next one, the cons is, it is implementation of this process is too difficult. Then the fourth one we have something is geographical based routing protocol. These are the location based information instead of routing tables. Instead of routing tables, we have something called location based information, and which has a greedy perimeter stateless roaming concept has been routing is being used. It relies on the GPS location instead of maintaining the routing table, and the nodes is going to forward data to the closest destinations. The positive point for this The scalability for the larger networks, low routing network overheads, and the cons is requires the GPS, which may not be available indoors. Next one, the hierarchy. Here the hierarchy protocol, it is going to have the routing protocols. These organizes nodes into the cluster for the scalability, and here the nodes are grouped into clusters within a cluster head, that is CH, managing the routings. So we have something called the host in the case of CBRT, that is cluster based routing protocol. That is, we have efficiency for the larger network and reduce the congestions as well as in the group node. The cons is the cluster information requires extra overhead. So we will see next the comparison of all the routing protocols. So when you take a proactive, it has a low latency, avoid loops, and the cons is high overhead. And the proactive, that is, we have something fast routing updates, and in the cons, no efficiency for the past networks. The reactive, we have something overhead, efficiency, high routing, discovery, low packet, everything we have. This is what we have discussed in the previous slide. So this is a general comparison table which we have here. Next, we'll see about the commercial mobile operating systems. What are the commercial mobile operating systems we have? So we know very much familiar in this particular topic. So it is a software platform that manages mobile devices, hardware and the softwares, enabling the applications to run efficiently. And the mobile operating systems are designed for the tablet phones, smartphones, tablets, as well as the wearable devices, and focuses on the touch screen interfaces, security, and the connectivity. The popular commercial mobile operating systems are Android, iOS, and Harmony OS, and KOS, as well as the Windows 10 mobile. So these are all the different mobile operating systems, and we know developers is Android is Google, and iOS is for an Apple, Harmony OS for Huawei, and the KOS for the KOS technology, and Windows is for your Microsoft. So these are all the mobile operating systems. Then we will see one by one in detail. So when you talk about an Android OS, it is developed by Google. That is the first release in 2008. The latest version of the Android is 14, and the programming language what we have used is Java, Kotlin, and as well as the C++. The devices used in the devices which is used on OS is smartphone, tabs, smart TVs, smart watches, IoT devices, etc. And the features here is the open source as well as the customized. The Google Play stores will have millions of the applications to have it in it, and multiple device manufacturing, that is Samsung as well as OnePlus, etc. is also supports, and multitasking widgets as well as the voice assistant, that is Google Assistant is being built in with, and 5G AI and the machine learning integration is also there. Next, the challenges is the fragmentation process is difficult, and also the security concerns. It is due to the third-party apps. Next, the iOS, it is an Apple, developed by an Apple. First release was 2007. The latest version is iOS 0, that is iOS 17, and the programming language is what we have used here is Shift as well as the Objective-C. And the devices, iPhone, iPads, Apple Watches, Apple TV, is only for this particular devices, not for all the devices. And the features we have, it is highly secure and seamless ecosystem devices, and it is optimized for and also for the battery life. Features Siri, Face ID, iMessage, AirDrop has been involved in it, and this regular software updates for all the devices has been inbuilt with this particular operating system. The challenges is it is in a closed source, and limited customization will be there, expensive device compared to the Android. Then the next one, that is Harmonic operating system, which was developed by the Huawei, and the first release was 2019, and the latest device was the Harmony OS 04. And what are the languages has been used in the case of programming is ARC compiler, which using C++ as well as the Java. So devices is the smartphone, Apple TVs, smart TVs, as well as the IoT devices. And the key features in this is the microkernel architecture for the better security is being involved in it, and cross devices functionality like phones, watches, as well as the smart TVs. So no Google services as well as used in the case of Huawei and App Gallery. It supports Android applications. Challenges is the limited global adoption outside of the China, and the fewer apps compared to the Google App Stores as well as the App Stores. The next one is Kia OS. It was developed by Kia OS Technologies. The first release was 2017. The latest version it was 3.1, and the programming languages what they have used is HTML5 as well as the JavaScript. The devices which has been used in this use for this OS is the Future OS smart features as well as the smartphones. Next one, it runs on the low cost devices. It supports 4G, Wi-Fi, GPS as well as the basic apps. The pre-installed with Google Maps is also supports YouTube as well as Maps Assistant is being involved in it, and low power consumptions, which also has an idea for emerging markets. So challenges in the case of the OS is a limited app ecosystems, not suitable for the high-end smart systems, smartphones users. Next, the Windows 10 operating system, which has discontinued because the first release was 2010 as a Windows phone. Latest release was Windows and Mobile 10, which was latest release of 2015. The programming language what it has been used is C++ and C#. The device Microsoft Lumina phones disk. So this particular operating system it was there in the period of 2010 to 15, but it was now not in use. Next, what are the features we have here in the case of is Live Tile UI is being used integration with a smart. It is going to use in the Windows PCs as well as Microsoft services OneDrive as well as Office and Cortana, and the secure operating systems with sandbox tabs has been used. The challenges what we have in the case is lack of developer supports and also the application ecosystems is there, and discontinued in the 2009 due to low market share. So these are all the topics we have discussed. Hope you all understand this. So thank you for listening. We'll continue this for we'll see the next topic in some other session. Thank you.